right, so integral of trigonometry function that involves secant and tangent, and when the power of the secant and tangent are both odd, okay? So when the power are both odd, we're gonna save one secant tangent and let u equal secant, okay? All right, so seeing they both are the odd power, I'm gonna save one secant tangent. What did that mean? That say save one secant tangent. It means I'm gonna take one secant from the secant to the power 7. So I left with secant 6 and then tangent 4, 3x. And then I bring that out here. So secant 3x, tangent 3x dx. Okay, so I'm saved one of them right here. And then I left with 6 power and 4 power. And then now I'm gonna let u equal secant. So u gonna equal to secant 3x. So this will give me the derivative will be derivative of secant is secant tangent. So that's the reason why we save one of them. So, but don't forget there's a chain rule. So there's a 3x. So we're gonna we must bring 3 in the front, and then we have secant 3x, tangent 3x, dx. Okay, and notice that secant 3x tangent 3x dx is actually the part that where we save. We don't need to get rid of the 3. So I'm going to divide both sides by 3. So we will have 1/3 du is equal secant 3x tangent 3x dx. So this part right here will nicely make the become 1/3u. So our integral now will become let me go back to substitute that. So now this part right here will become 1/3 du. So I'm gonna bring the 1/3 to the front, and then that become du. And for my secant is u. So my secant right here, this is gonna be u to the power 6. So u to the power 6. The only thing that we have to deal of is the tangent. We don't have anything that to substitute for tangent. So we need to take care of tangent. We're gonna make tangent 4 to the power 4, 4x, 3x. Tangent to the power 4, 3x become tangent to the power 2, 2x. And then the whole thing squared. And we have the identity that 1 per tangent squared is secant squared. And tangent squared is secant squared minus 1. So we're going to have secant squared 3x minus 1. And then the whole thing to the power 2. Okay, so that will make this, and our secant is u, so it's going to become u squared minus 1 to the power 2. If I expand this one, I'm going to have u to the power 4 minus 2u squared plus 1. And I'm going to carry that on this side. I have u to the power 4 minus 2u squared plus 1, and then du. So now we're gonna turn our integral of trigonometry function to some algebraic function that is easy to take the integral. The last step we need before we taking an integral is we need to distribute this. So I have 1/3 u to the power 10 minus 2u to the power 8 plus u to the power 6 du, and 1/3. We're gonna integrate this. Whenever we integrate a power function, we're gonna have to increase the power and divide that new power. So the 10 will become 11, right? So we're gonna have u to the power 11 over 11. Or you can do 1/11 u to the power 11. And then 2u9 over 9 plus u to the power 6 over 6. And then plus c. Okay, so this is where we already integrate. And the last step is we're gonna substitute the secant. So we have 1/3 secant to the power 11 3x over 11 plus minus 2/9 secant to the power 9 3x. and then plus 1 over 6 secant to the power 7 3x, and then plus c. Okay, so this is going to be the final answer. Oops, I think I make one of the mistake when I increase the power, I forgot to divide the new power. And that is a good mistake because this always happen. So just keep in mind whenever you take the power rule for the integral, you increase the power, you need to divide that new power. So this, instead of 6, I should have 7. 7, and then this is going to be 1 over 7 instead. All right.